firm's short-run environment has many fixed limitations. However, the firm has significant flexibility in the long run. In this lecture, we're going to look at changes in plant capacity made by a single firm over time and explore the concept of economies of scale. We'll use economies of scale to link a firm's size and its average cost in the long run. We'll give some examples of economies of scale and review the concept of minimum efficient scale, or MES, the range of output where long-run costs are minimized. In the long run, the firm can change all input variables, including plant size and equipment. In the long run, there are no fixed costs. It's all variable, both for increasing resources and, where it's warranted, decreasing resources, including buildings and equipment. Both management and the market can make these types of adjustments in the long term. Thus, the average total cost curve can be changed over time. This chart represents the various plant sizes that a single manufacturer can implement to increase production over time. Each plant size has a low point on the average total cost curve. Suppose a manufacturer with a single plant begins on a small scale at average total cost 1 on the left-hand side of the chart. And as the result of successful operations, continues to increase capacity within the single plant, ultimately achieving an average total cost position represented by the blue line at average total cost 3. We can say that the firm has continued to achieve economies of scale up to the blue line. Okay. We can say this firm has continued to achieve economies of scale up to the blue line at average total cost 3. So I've drawn a blue line here, kind of representing they've got to the low point. Stated differently, continued increases in fixed cost has decreased the average total cost through the low point at average total cost 3. You can see that this transition is not always smooth. The move from ATC1 to ATC3 can be a bumpy road and may take considerable time. The move from ATC1 to ATC3 represents a single firm generating economies of scale. In the long run, the firm can end up at any point on the U-shaped curve. The number of plant and equipment configurations are unlimited. However, at each plant size, there is a low point on the average total cost curve. In the long run, there are configurations that enable economies of scale and those that lead to diseconomies, or plant and equipment configurations that have their own average total cost that is low, but in total continue to increase average total cost. So here you can see that at each one of these various plant sizes that you can configure in the long run, there is a low point on the average total cost curve. But there is only one configuration that leads to the lowest average total cost of all of the configurations. And once you get beyond that point, and firms do, once you get beyond that point, you can be operating at your low point on the total cost curve, but also have diseconomies relative to the average total cost curve that would be represented by ATC3 here. The firm can produce more output, but not as cost effective. The firm could also be putting itself in a position at ATC5 that exposes a weakness to a firm that maintains output at ATC3. In essence, a competitor with a lower cost position. Okay, so this in essence captures the whole range of average total cost on the vertical axis and output at various stages of long run activity across the horizontal axis. Picking the point on this cost curve is both a long-run decision and a decision to understand whether you're operating at economies of scale or diseconomies of scale. There are reasons why firms achieve economies of scale. By organizing labor. Jobs that labor must perform can become more and more specialized, performing limited tasks that just become more efficient. Likewise, management can supervise more individuals without a big loss of control. So as you can see, ATC1 to ATC3, as you move and change, you can make specialization and you can get to the point where you're still at a place where, management knows all of the workers, understands how the system operates, and don't have a loss of control. Capital expenditure decisions many times are based upon the expected level of maximum output. If the volume is expected to be 1,000, there may be only a certain type of equipment that will pay for itself. However, if volume is expected to be 10,000, then a more expensive, more productive, and efficient level of investment can be made. Stated differently, volume pays for the capital expenditure. You may not know that level of activity when you start out at ATC1 because you're starting out. You may not know that the market truly is 10,000 versus the initial 1,000 that you estimated, okay? And that's as you get the volume and you understand that your volume's there, the volume ultimately pays for the capital expenditure and you can lower your overall average total cost. Finally, other costs like initial research, startup costs, and advertising costs can be spread over a larger volume. In many U.S. manufacturing industries, economies of scale have been of great significance. Firms that have expanded their operation to obtain economies of mass production have survived and flourished. Those unable to expand have become relatively high-cost producers, doomed to struggle to survive. Practical word of caution. Economies of scale requires a certain level of output. If a particular firm has an average total cost curve achieved with 10,000 units of production, then it must continue to produce at that level to get economies of scale. If more competition enters and cuts their volume down to 5,000, then adjustments to costs must be implemented to survive. So when I look at that previous chart and that previous graph of moving from ATC 1 to 3, there are times when management to survive needs to move from ATC 3 back to ACT 2, depending upon the level of competition that exists. We've already seen that economies of scale is not present over the complete range of long-term production options. Diseconomies of scale enter when the process becomes too complex. A firm can grow to the point when control over daily operations is beyond the capabilities of management. The firm becomes too big for its britches. Decision-making takes longer. Getting the word out on regular production takes longer. Communication is less effective because the organization is too large. Importantly, key decisions about ordering material, scheduling shifts, or organizing weekend overtime may end up ineffective. Workers become dissatisfied. They are no longer getting the coaching they received in the old days. The place becomes so large that people can actually hide and shirk their work. Management may need to hire more supervisors to maintain control, which increase costs. I want to talk about and give a specific example of shirking work and how we attempted to overcome that situation in the parts business. Typically, parts warehouses, that is, service parts warehouses that house all of the parts for automotive companies, are large. Lots of parts and lots of places to hide. So there are all of these stories about, people coming in and punching their clock and then walking to the far reaches of the parts warehouse to find some nice, comfortable bin to go to sleep in for the first 4 hours because the place was so big that management didn't know where they were at. Well, one of the ways that that problem was solved was to, in essence, measure the work of each of the individuals in terms of the time it took to place an order. And so the system was designed on a card system that basically said the worker in an 8-hour day had to fulfill about 10 to 12 runs of picking parts throughout the warehouse. Some were longer, some were shorter, but each one had their own little card system that was very visible, and you couldn't pull your card from the system until you had done your particular workload. Very visible to management of who was working and who wasn't, based upon all the people that were supposed to be doing those jobs. Suffice it to say that the union didn't like that particular approach because it was too much like an assembly line. And so, unfortunately, that particular work was eliminated, but it is a strong memory to me that an organization and the size of a plant can get so large where people can really and do shirk their responsibilities and hide. Looking at the long run. In some industries, a rather wide range of output may exist between where some get economies of scale and others get diseconomies of scale. Every firm is not the same. There may also exist an output and average total cost structure that falls within the range of minimum efficient scale, or MES. And that's shown here in the middle, okay? In the previous chart, it kind of implied that, the curve was a lot deeper. In this particular case, the curve is much more shallow and probably reflects more real-world considerations, that there is a wider range of potential output and plant configuration where you actually get constant returns to scale rather than hitting that wall in diseconomies, okay, which kind of was implied from the previous graph. And minimum efficient scale happens when there is a wide range of potential output that delivers the same average total cost. This is shown on the graph where the average total cost curve is flat across that wide range. The lowest average total cost is generated at output Q1, shaded in blue. So the firm operating in this industry at Q1 production level would generate the lowest average total cost. However, the firm producing at Q2 would also have the same average total cost. Thus, in this industry structure, there can be a number of different sized firms generating the same average total cost. There is a minimum efficient scale that can be achieved at a relatively low level of production. Small regional firms can have the same average total cost structure as larger firms covering a wider area. To conclude, not all industries have a long-run cost structure where the lowest cost is achieved over a wider range of volume. In other industries, it takes a high level of output, very high level of output, to achieve the lowest average total cost. This type of structure exists where there is a high level of investment, capital structure, and extensive research and development required to meet customer requirements. Small firms can't realize the lowest possible cost and will be unable to compete. The automobile, steel, and other heavy industries reflect this type of output and cost structure.